The speed, also that speed is very high, that electronic speed, electron that is revolving around that orbit, that speed is very high, of the order of 10 to the power 6 meter per second. Due to this very high speed, that electron is treated like a relativistic particle. Also, you have learned that energy level or electronic energy level of hydrogen atom is discrete in nature. Like first orbit, the ground state energy was how much? That yesterday we have calculated. Ground state was energy was how much? Any people? Anju? How much energy that we have seen last yesterday?
Minus 13.6
Unit?
electron volt. Energy.
Okay, very good. Then second energy, first excitation energy is how much? Anushka? We have calculated that first excitation energy of that hydrogen atom. That energy was how much? Minus 3.4 electron volt, right? Is not it?
Yes, sir.
Yes. Then how much was that the separation between these two energy level, E1 and E2? Dhruvi? How much was that?
Sir, 10.2 electron volt.
Okay, very good. Okay, so today we'll learn that about that hydrogen-like atom.
Sir, please start your recording also.
Yes, yes, sure. Thank you. So today we'll learn about that hydrogen-like atom. And that atom is, Anju, can you please tell me that name? Hydrogen-like
Helium, lithium, beryllium,
helium plus, right?
helium plus,
Helium plus, then
lithium,
2 plus, then beryllium 3 plus, etc. So you see, helium plus means it has how many nucleon? Helium plus means it has 2 proton, 2 neutron, but only 1 electron, right? Anushka, I'm saying correct? Helium plus means there is 1 electron, but 2 protons are there and 2 neutrons are there. Similarly, lithium 2 plus, it means it has only 1 electron, but it has 3 proton and 3 neutron, right? So due to this 1 electron, it is called hydrogen-like atom, because in hydrogen you have only 1 electron. So what is basically happening for this system? If you draw orbit, suppose you have, this is your nucleus, and this is your electronic orbit. So in nucleus, the charge will be how much? It depends on atomic number, right? Suppose that atomic number is Z, then charge will be how much? Z into E. Z is the atomic number. So what will be the Z for helium? Dhruvi? How much will be the Z for helium? Helium plus. Can you please tell me? For helium plus, Z will be how much?
2.
Very good. It will be 2. Then for lithium, Anushka, can you please tell me that? For lithium, how much will be that Z? Can you please tell me? So for lithium double plus, Z will be how much? 3, right? Because atomic number of lithium is how much? 3, right? Is not it? I'm saying correct or not wrong?
Yes, sir.
Okay. Now see, that electron is revolving and you have that ZD amount of positive charge at nucleus. Then how much will be that Coulombic force? Let us assume that Coulomb force is F1. It will be how much? Coulomb force act on this electron due to that positive charge. It will be simply 1 by 4 pi epsilon naught into Z E square divided by R square, if that radius is R. Every people agreed? Is not it? So for
Yes, sir.
so this force is actually acting towards the nucleus. Okay, so this is your Coulomb force F1. Now due to that orbital motion, another force will act outwards. Okay, that force is centrifugal. That force will be how much? If the speed of revolution is v, then that centrifugal force will be how much? Anyone?
MVR, MVE.
So it will be simply me, mass of this electron, into v square divided by r. Is not it? This is your centrifugal force. So centrifugal force acting outwards, that is me v square by r, and the Coulombic force acting towards center or inwards, that is 1 by 4 pi epsilon naught z E square by r. Since this orbit is stable, so these two forces are balanced, is not it? Yesterday we have seen for same thing for hydrogen atom. Now we'll derive same thing, that like expression for radius, expression for speed, and expression for energy for hydrogen like atom. Now we will see that Z will come to that picture. Z is the atomic number of atom. Okay, like for helium Z is 2, lithium Z will be 3, beryllium Z will be 4. So now if we equate these two equations, and this should be equal, these two forces should be equal because this orbit is stable. Now if you equate it, so what is the condition? F1 should be equals to F2. Why this should be equals to F2? Shekhar, can you please tell me why F1 and F2 are equal? Shekhar, can you please tell me? Can you please tell me why F1 and F2 are equal? Because that orbit is stable, right? So orbit is stable means what? That inward force and outward force should be balanced, so that electronic position should not be changed. Did you get what I'm saying? Did you get? Any problem, Shekhar? Is there any problem? So these two forces should be equal. So it means 1 by 4 pi epsilon naught into Z E square divided by R square should be equals to how much? ME V square by R. And yesterday we have seen that orbital angular momentum MVR or MEVR is quantized in nature, NH cat, where N can run from 1, 2, 3, so on. So from this equation you will get V equals to how much? NH cat divided by ME into R. Now if you substitute this speed here in this equation, then what you will get? You will get on the left hand side, it will be same 1 by 4 pi epsilon naught into Z E square by R square should be equals to ME divided by R. Now V will be how much? V will be simply NH cat divided by ME into R, and V square means square of this. Every people got? Anju, did you understand?
Yes, sir.
Anushka, did you understand?
Yes, sir.
Ruby, did you understand?
Yes, sir.
Shekhar, did you understand? Okay. So from this equation, can you sorry, can you please tell me that radius will be how much? So if you solve this equation, so this is R square, this R square will be cancelled, and if you solve this for hydrogen and like atom, you will get 4 pi r equals to 4 pi epsilon naught n square h cat square divided by z into me e square. Okay. So this is the expression for speed for hydrogen like atom. Yesterday we have learned for hydrogen atom. Now what is the extra factor here for hydrogen like atom? Anyone in the class? What is the extra factor here? Anyone can please tell me that what is the extra factor in that radius of expression? Anyone? You see, the Z is the
Z.
very good, very good. So Z is the extra factor. Now, if you remember, yesterday we have seen the Bohr radius, right? And that was A naught equals to how much? 4 pi epsilon naught h cat square divided by me e square, and that value was how much? 0.53 angstrom, right? Did you get what I'm saying? This was your A naught. A naught means 4 pi epsilon naught h cat square divided by me e square. Now if you substitute this A naught here, you will simply get the radius of nth orbit of hydrogen like atom will be how much? Simply n square A naught divided by z. Now can anybody tell me that what will be the radius of helium plus ion for n equals to 1? For n equals to 1, how much will be the radius of helium plus ion? How much it will be? Anyone? So simply here n will be how much? On. So on into A naught, and for helium plus Z is how much? For helium Z is 2, right? Is not it? I'm saying correct, right? Is there any doubt?
Yes,
So
sir.
for n equals to 1, for helium plus Z is how much? Z is on. Now for n equals to 1, you will get R1. You will get R1. R1 will be how much? Simply n on square into A naught divided by 2. So it is simply A naught by 2. And you know that the value of A naught, right? Did you get? तो फर्स्ट ऑर्बिट का हीलियम का रेडियस ज्यादा होगा या हाइड्रोजन का? किसका ज्यादा होगा? फर्स्ट ऑर्बिट का रेडियस हीलियम का ज्यादा होगा या हाइड्रोजन का ज्यादा होगा? अनुष्का, कैन यू प्लीज टेल मी व्हिच वन विल हैव हायर और लार्ज रेडियस, हाइड्रोजन और हीलियम प्लस?
Hydrogen.
For hydrogen, how much it will be? For hydrogen, how much it will be? Yesterday we have seen, right? For n equals to 1 or ground state, that radius was simply A naught, right? For hydrogen atom. Did you get what I'm saying? So for hydrogen atom, the radius of first Bohr orbit is simply A naught. A naught is how much? 0.53 angstrom. Then also you have seen yesterday that for n equals to 2 or first excited state, that radius of orbit is 2 square A naught. 2 square A naught means 4 A naught, where A naught is the Bohr radius. For second excited state, n is 3. So for second excited state, that Bohr radius for hydrogen atom was 9 A naught. Now if you see for helium plus extra factor is Z, and that is actually in denominator. So for ground state, radius of or electronic radius of helium plus ion will be A naught by 2. This is half of the radius of hydrogen atom. Okay. Similarly, you can calculate for other orbit. Just you have to substitute n values, right? Like for first excited state, n will be 2. For second excited state, n will be 3. Please keep in mind, first excited state means not n equals to 1, it is n equals to 2. Okay, so for hydrogen like atom, extra factor is Z. So this is the expression for radius. Now can you tell me that expression for speed? Anyone? Shekhar or Anju, anyone? Can you please tell me that expression for speed for hydrogen like atom? So you have, you know this formula, MEVR equals to how much? NH cut. Now you know these values, right? This is this. So if you substitute it here, this is ME into V. Now we'll substitute this. This is actually how much? 4 pi epsilon naught, then N square H cut square divided by how much? Z mass of electron into charge of electron square. That should be equals to how much? NH cut. Is not it? Did you people get what I'm saying? Just what you have to do, you have to substitute this R. That R you know now. If you substitute this R, you will get expression for V. V is the speed of electron for hydrogen like atom. So what you will get? What will get that output? जरा बताइए, नीतू जरा बताइए कितना मिलेगा? Can you please tell me? So speed will be how much? If you see, it will be E square by 4 pi epsilon naught, then NH cut, and in numerator you will get extra factor Z, that is Z. Z is the atomic number. Okay. Now, if you remember yesterday we have defined one factor, that is fine structure constant, right? If you will remember that. आप लोगों को समझ में आ रहा है क्लास में? अंजू समझ में आ रहा है क्लास में?
Yes, sir.
अनुष्का समझ में आ रहा है?
Yes, sir.
ध्रुवी?
Yes, sir.
शेखर? Neetu? Did you get what I'm saying? Okay. So you see, yesterday we have defined fine structure constant. How much it was? Anju, can you please tell me? How much it was? So it was.
Alpha equal to
Sorry, your voice is not.
4 by H cut C.
It was like E square by 4 pi epsilon naught H cut C, right? Now if you bring this equation or insert this equation here, you will get expression for speed as a function of principal quantum number small n, and that should be how much? ZC alpha by n. Okay, so you see that extra factor is coming. So for helium plus, that speed will be high. Like for same n, if you take hydrogen atom and helium atom, then electron for n equals to 1, which one will have higher speed? Helium plus, right? Because for helium plus Z is 2. So if you calculate that speed for helium atom or helium ion, helium plus Z is 2, then speed of electron at n equals to 1, that speed will be how much? Simply V1 equals to 2C alpha, and that value will be how much? 2 times 2 into 1.9 into 10 to the power 6 meter per second. Did you people get what I'm saying? So helium हाइड्रोजन के लिए कितना था ग्राउंड स्टेट में? जो स्पीड था कितना था? Simply 2.19 into 10 to the power 6 meter per second. But for helium, how much it is now? 2 into 2.19 into 10 to the power 6 meter per second. So the speed is increased by twice, right? So lithium के लिए कितना हो जाएंगे ये? 2 के जगह पे just कितना हो जाएंगे? 3 हो जाएंगे, right? Because for lithium double plus, that Z value is how much? Z is the atomic number. It is 3, right? Is not it? Did you people get what I'm saying? Is not it? So you got expression for speed and radius for hydrogen like atom. Now we'll calculate the expression for total energy for hydrogen like atom. क्लास में किसी का कोई डाउट है आप लोगों का? एक एक करके बोलिए जरा। आप लोग कंफर्टेबल है क्लास में?
Yes, sir.
कोई अच्छा are you people enjoying that class? Okay, so now we'll calculate the total energy. So total energy basically denoted by capital E, and that capital E should be equals to how much? Its kinetic energy plus its potential energy. And kinetic energy will be how much? Simply half mass of electron into V square. Then potential energy how much? Now potential energy will be Z E square by 4 pi epsilon naught Rn, right? So for hydrogen atom, if you remember yesterday, we have taken only minus E square by 4 pi epsilon naught Rn. For hydrogen like atom, you have to bring that Z number, because charge at the nucleus now how much? That is plus Zt, right? So potential energy will be modified for hydrogen like atom. Now it will be minus Z E square by 4 pi epsilon naught Rn, and this is the kinetic energy. Now if you calculate that kinetic energy, if you substitute that speed, so it will be how much? Simply, so kinetic energy equals to half into mass of electron into V square, and we know that speed, that is how much? E square Z by 4 pi epsilon naught n h cut and its square, right? Because V square. Okay, now if you calculate it, you will get m e square me e to the power 4 z square divided by 32 pi square epsilon naught square n square h cut square. H cut means how much? H cut means h by 2 pi. It is basically reduced Planck constant. So this is the expression for kinetic energy, and potential energy will be how much? Just you have to substitute that expression for radius you got, just you have to substitute this. Okay, can you people calculate that potential energy? Anyone in the class? Can you people calculate it? So yesterday we have derived what equation? You remember potential energy is how much? Minus twice of kinetic energy, right? If you will remember that. Okay, Anushka, you remember that formula?
Yes, sir. From
And you?
planetary motion.
Yes, yes. For planetary motion, and same is true here also. Hydrogen atom and hydrogen like atom. Anju, are you agreed?
Yes, sir.
Neetu, are you agreed? So if you see,
Yes, sir.
yes. Now potential energy will be how much? It will be minus twice of kinetic energy. Okay. So total energy will be how much? Can you, anybody can please tell me? The total energy will be how much? आप लोग अच्छे से कीजिए, है ना? ये आपका बेस्ट प्लेटफॉर्म है लर्न करने के लिए, फिर आपको अच्छा रैंक मिलेंगे, फिर अच्छी जगह पे आप लोगों को एमएससी के लिए मिल जाएंगे, है ना? फिर अच्छी जगह पे आप लोग रिसर्च करोगे, है ना? ये बेस्ट टाइम है अच्छे से पढ़ने का, है ना? और क्लास में कोई भी डाउट हो हम लोगों को पूछ लीजिए, है ना? वैसे मैं 4 बार जीआरएफ क्वालिफाई किया हूँ, मेरा गेट जेएसटी सारे है, और मैं टॉप 20 में 2 बार आया हूँ जीआरएफ में, ठीक है? तो ये आपका पोटेंशियल एनर्जी कितना है? ट्वाइस ऑफ काइनेटिक एनर्जी। तो टोटल एनर्जी कितना हो जाएंगे आपका? kinetic energy, and in place of kinetic energy how much we will keep? Anyone? So potential energy is how much? It is basically minus twice of kinetic energy, right? So basically how much you will get? Total energy will be basically simply minus of kinetic energy. ठीक है, जो टोटल एनर्जी होगा आपका वो कितना होगा? माइनस ऑफ काइनेटिक एनर्जी दैट वी हैव डिराइव्ड. ओके, जस्ट क्या क्या मैंने काइनेटिक एनर्जी एज इट इज रखा हूं. पोटेंशियल एनर्जी कितना है? माइनस ट्वाइस ऑफ काइनेटिक एनर्जी. So kinetic energy minus twice of kinetic energy will be how much? Simply minus kinetic energy. And minus kinetic energy means minus me e to the power 4 divided by 32 pi square epsilon naught square n square h cat square into z square. Now if you substitute that value of mass of electron, charge of electron, epsilon naught and h cut, you will simply get minus 13.6 into z square divided by n square. So this is the energy expression for nth level of hydrogen like atom. So we'll get extra factor, that is z, in the energy expression. Not z actually, this is z square. Okay, कोई डाउट है आपका? ध्रुवी समझ में आया आपको? हाँ. अनुष्का समझ में आई?
Yes.
नीतू?
Yes, sir.
Okay, very good. Anju?
Yes, sir.
Okay, so this is the energy expression. तो हीलियम का ग्राउंड स्टेट एनर्जी ज्यादा होगा या हाइड्रोजन का? एनीवन इन द क्लास? हाइड्रोजन का ज्यादा होगा?
Helium. Helium.
हीलियम का ज्यादा होगा? कोई अच्छे से बताइए. हीलियम का कितना होगा? कैलकुलेट कीजिए और मेरे को बताइए जरा. हाउ मच विल बी द ग्राउंड स्टेट एनर्जी ऑफ हीलियम प्लस आयन इलेक्ट्रॉन इन द हीलियम प्लस आयन? हाउ मच इट विल बी? कैलकुलेट कीजिए, मैं टाइम दे रहा हूं आप लोगों को. How much? Anyone?
54.4.
Huh? Yes.
54.4.
Okay. So ground state energy of helium will be how much? Minus 54.4 electron volt. This is for helium plus ion, right? Now, for if you remember yesterday we have seen for hydrogen energy was how much? 13.6 electron volt for hydrogen, right? अब इनमें से कौन बड़ा है बोलिए जरा? माइनस 54.4 बड़ा है या माइनस 13.6 बड़ा है?
Minus 13.6.
वेरी गुड. तो कंफ्यूज आ गया था ना? ऐसा लग रहा था ना हीलियम का ज्यादा है, बट इट इज एक्चुअली नेगेटिव, राइट? इज नॉट इट? इफ यू टेक मैग्नीट्यूड देन ऑफ कोर्स हीलियम का ज्यादा होगा, बट सिंस इट हैज नेगेटिव साइन दैट्स व्हाई ग्राउंड स्टेट एनर्जी ऑफ हाइड्रोजन विल बी हायर देन द ग्राउंड स्टेट एनर्जी ऑफ हीलियम. ओके, अब हम लोग शुरू करेंगे स्पेक्ट्रल लाइन के बारे में. किसी को कोई इसमें आइडिया है स्पेक्ट्रल लाइन? इज देयर एनी आइडिया? एनी स्टूडेंट? किसी का कोई आइडिया है इसमें? प्लीज रेस्पॉन्ड मी सो दैट आई कैन प्रोसीड. So if you see spectral line, spectral lines, okay? In spectral line, what will happen? Suppose let us assume two levels. Suppose this is your NF is the principal quantum number of final state and Ni is the principal quantum number of initial state, and its energy, electronic energy is EI. For this level, energy is EF. Initial, also it is given that the energy of EI level, ith level is higher than final level. It means the energy of this state is higher than the energy of this state. And also let us assume electron is sitting here. Now what will happen? Anyone? What will happen? So आपका सपोज मान लो इलेक्ट्रॉन एक्साइटेड स्टेट में है तो क्या करेंगे कुछ टाइम बाद? Anyone? Shekhar?
It will emit energy and come to ground state.
Very good. What will happen? It will make transition because every system try to stay in ground state, right? So what will happen? It will make transition from this state to this state. As a result, what will happen? Nitu, what will happen? If it make transition from this level to this level, what will happen? What will happen? Anushka, what will happen?
It will have some wavelength.
Yeah. Yes, very good. Good idea. So what will happen? It will emit photon, right? It will emit photon. When it make transition, electron make transition from this to this level, it will emit photon, right? How much will be the energy of this photon, Anju? How much will be the energy?
I don't know, sir.
Okay. Anyone? Anyone in the class? How much will be the energy?
EF minus EI.
Is it correct? Anyone? Shekhar, is it correct? What he is saying? Is it correct?
No idea, sir.
No idea. Okay, no problem. I'll tell. So if you see, किसका energy ज़्यादा है इसमें? Which one is having higher energy? EI or EF? Which one is higher energy? EI or EF? EI, right? So Nitu was correct, but she make one mistake. She said EF minus EI. So, but always keep in mind that when electron is making transition from higher to lower level, then energy will be always used to write EI minus EF. But when electron make transition from lower to higher level, then we have to take EF minus EI. Nitu, did you get what I'm saying?
Yes, sir.
Yes, very good. Good idea. So what is happening? That energy of photon is represented as h nu, right? This is the energy of photon, right? ऐसे तो लिखते हैं ना energy of photon को h nu, है ना? And that also you can write as hc by lambda, because nu equals to how much? C by lambda, and that value should be equals to how much? EI minus EF. EI minus EF. Okay. अब इसको ग्राउंड स्टेट एनर्जी के फॉर्म में लिख सकते हो. सपोज यू हैव ग्राउंड स्टेट एनर्जी इज हाउ मच? सिंपली फॉर दिस सिस्टम लेट अस assume ground state energy is E1. So you can write this energy, EI energy or ith level energy will be how much? Simply if you write it, you will get, अगर कोई प्रॉब्लम हो तो बताना. अगर इसको आप लिख सकते हो सॉरी, E1 Z square divided by Ni square. So EI, this energy you can write in terms of ground state energy. Just now I have derived. For hydrogen-like atom, the energy of nth level can be written as minus 13.6 Z square by N square. Minus 13.6 is the ground state energy. Okay. So, or you can write it is like E1. So E1 into Z square by N square. So Z is the atomic number of this species. So this is the energy of ith level. Ni is the principal quantum number of this level. समझ में आया ध्रुवी मैं क्या बोल रहा हूँ?
Yes, sir.
ध्रुव, अनुष्का समझ में आई?
Yes, sir.
Anju, did you get what I'm saying?
Yes, sir.
Shekhar, did you get what I'm saying?
Sir. Get.
Nitu, did you get what I'm saying? Did you get, Nitu? Okay, so this is the energies. Also, you can write that final state energy will be how much? Anyone? So you can write in terms of ground state energy, that is E1 Z square divided by NF square. Okay, so this will be the energy. Now if you take minus E1 Z square common, minus E1 Z square common, then what you will get? You will get simply minus 1 by NF square minus 1 by Ni square. यही तो आएंगे ना, है ना? यही तो आएंगे. अगर आप यहाँ से अगर माइनस E1 Z स्क्वायर कॉमन लोगे तो क्या होगा? 1 by NF स्क्वायर माइनस 1 by Ni स्क्वायर. Okay, did you get every people what I'm saying?
Yes, sir.
Very good. So you please keep in mind. Now we'll go for different series. So please keep in mind that energy of this outgoing photon, that is h nu, and that is nothing but hc by lambda, and that value should be minus eon z square, where eon is the ground state energy of hydrogen atom, z square, z is the atomic number of this species, and 1 by nf square, nf is the principal quantum number of final state, and 1 by ni square, ni is the principal quantum number of initial state. Okay. What is the time now? Yes. So now we'll go to Lyman series. So what is Lyman series? Anyone? Anyone in the class? So that energy you wrote, right? hc by lambda equals to minus eon z square into 1 by nf square minus 1 by ni square. So when nf, I mean final state quantum number is on, and ni can be 2, 3, 4, 5, so on. So we'll get that spectral line. So basically electron is coming where, which state? Final state is on. It means it is coming to ground state from other state, like n equals to 2, that electron is going to transition from to n equals to on. Then also from n equals to 3, it is making transition to n equals to on. N equals to 4, that electron making transition to n equals to on. So then you will get Lyman series. Did you people get what I'm saying? Suppose this is your n equals to on, and from other state, if that electron is making transition, so you'll get on series of line, that is known as Lyman series. And basically this series or this line found in UV region. UV means what? Anju, what is the meaning of UV?
Ultraviolet region.
Oh, yes, very good. So how much will be the energy of this UV? Nitu, can you please tell me? How much will be that energy UV? It is higher than visible or less? Sekhar, can you so UV energy will be higher than visible, right? Is not it? UV energy is higher than the visible light, right? And that energy, if you see, that range is basically 3.2 electron volt to 12.4 electron volt. Okay, this is the energy range of UV light. So all that Lyman series or Lyman series you will get in UV range. Okay, so this is your Lyman series. Now we'll go to Balmer series. What is Balmer series? Anyone? What is Balmer series?
Where NF is equal to 2.
Okay, then what about Ni?
Can be 3, 4, 5.
Very good. So in Balmer series, your NF is how much? NF is 2, and Ni can be 3, 4, 5, 6, and so on. Okay, then you will get that spectral line, and that spectral line is Balmer series. And that Balmer series basically found in which range or which region? Anyone? Nitu? Dhruvi? Can you please tell me which region you will get it?
Visible region.
Visible region. Every people agreed what he's saying? Is it correct? Is it correct what he is saying? Is it correct? So basically this Balmer series is found in correct actually. It is found in visible range. And if you see that energy of visible range, it is basically range from 1.7 electron volt to 3.2 electron volt. So this is the energy of visible range, and all that Balmer line you will get in visible range. Okay. Then you have next is which line or which series? Anyone? Anju?
Passion series.
Passion series. Very good. Passion series. And for this, N is how much? NF is how much? It will be how much? 3, right? And Ni can be 4, 5, 6, 7, and so on. Okay. Then you have which one? Bracket, right? For bracket series, so that Passion series is basically found in which range? IR, right? IR means you know na? What is the meaning of IR? IR means infrared, right? So infrared has less energy as compared to visible light. It means infrared has higher wavelength as compared to visible light. Okay, so you have Passion series. Next is bracket series, right? For bracket series, NF will be how much? NF will be 4, right? But Ni will be 5, 6, 7, 8, 9. And bracket series also found in which range? It is in IR range, right? Did you people get what I'm saying? Okay. For then next series is which one?
Open series.
So for bracket series आप लोग नोट बना रहे हो क्लास में? Extremely sorry. Are people making note? Okay. So
Yes,
for
sir.
bracket series, NF will be how much? 4, right? And that Ni can be 5, 6, 7, and so on. Okay. Then you have Fund series. For Fund series, NF is how much? NF will be basically 5, and Ni can be 6, 7, 8, 9, so on. Okay. So bracket series also found in IR range. Fund series also found in IR range. Next. Any more series you learned? Anyone? Next is Humphreys series. Humphreys series. For Humphreys series, NF will be how much? Anyone? NF will be how much?
6.
Very good. NF will be how much? NF will be 6. And Ni will be how much? 7, 8, 9, and so on. So this all series, bracket, Fund, Humphreys, all basically found in IR range. Okay, please keep in mind. Okay, now we'll see that spectral line of hydrogen atom particularly, because this is very important in experimental perspective. So we'll see that spectral line for hydrogen atom. So please keep that heading. We'll learn details about that spectral line of hydrogen atom. Okay, so if you remember, that formula was Hc by lambda equals to how much? Minus E1 Z square. For hydrogen, Z will be how much? For hydrogen, Z will be how much?
1.
Very good. So basically you will get minus E1 into 1 by NF square minus 1 by Ni square. Is not it? Okay. So Hc by lambda equals to basically minus E1. E1 is the ground state energy into 1 by NF square minus 1 by NI square. Okay. Now if you bring HC this side, basically what you will get? You will get 1 by lambda equals to minus E1 by HC. Okay. E1 by HC into 1 by NF square minus 1 by NI square. Minus E by HC. What is this quantity called? Anyone in the class? Minus E on by HC. This quantity is called Rydberg constant, right? This is known as Rydberg constant. So this quantity minus E1 by HC basically Rydberg constant, and it is denoted by R. So what you will get? You will basically get 1 by lambda equals to R into 1 by NF square minus 1 by NI square. Okay. So E on is the ground state energy, that is basically minus 13.6. H is the Planck constant, C is the speed of light. If you substitute all this value, you will get R, that is Rydberg constant, and that value, anyone? Value of Rydberg constant 1.09 into 10 to the power 7. What is the unit of Rydberg constant? Anyone in the class? What will be the unit? Anyone? It is basically in meter inverse, right? So this is the value of Rydberg constant, and the unit of Rydberg constant is meter inverse. Please keep in mind. Okay. Now, so if you got that expression for 1 by lambda for hydrogen atom, it is basically R times 1 by NF square minus 1 by NI square. Now what will happen to Lyman series or Lyman series? So what will happen to Lyman series? So 1 by lambda for Lyman series, if you remember, for Lyman series, if you remember, NF was how much? On, and NI can be 2, 3, 4, and so on. What does it mean? It means 1 by lambda for hydrogen atom, it will be, sorry, R times 1 by 1 square minus 1 by NI square. Now what will be the, how much will be the maximum wavelength of Lyman series for hydrogen atom? When will be that maximum wavelength? For what values of Ni? Anyone? For what values of Ni, the wavelength of Lyman series will be maximum. Anyone in the class? Shekhar? What will be that Ni? So you see what is happening. This is your NF that is fixed now. This is on. Now electron is making transition from higher state. So you see this is N equals to 2, 3, 4. Now if electron is making transition from this N equals to 2 to N equals to 1, it will have less energy, right? Because this is the smallest separation. If you make transition from here to here, this energy is large as compared to this energy, right? Or if you are making transition for N equals to 4 to N equals to 1, this is large amount of energy. So this is the smallest energy. It means if the energy is small, lambda will be large, because E equals to hc by lambda, right? If the energy is small, then lambda will be large. So that means when Ni equals to 2 in Lyman series, then lambda will be maximum, right? If people got what I am saying? Every people, did you get what I am saying? What I am saying that
Yes,
when Ni equals to 2, then you will get the maximum wavelength of Lyman series, and that will be how much? If you keep the for lambda max will be how much? If you calculate it, you will get 4 by 3R. If you calculate that maximum wavelength, that will be basically 4 by 3R. And if you substitute that R value, that is basically 1.09 into 10 to the power 7 meter inverse, if you substitute it, you will get basically how much? 1216 angstrom. And that is lie in UV range. Okay. Now, what about minimum wavelength of Lyman series? Anyone? When will be the minimum wavelength? Anyone in the class? So this is the maximum wavelength when Ni is 2. Now, if you take Ni is infinity, so it means electron is coming from here to here. You see this energy gap is very high. It means that emitted photon will have largest energy. If the energy is large, it means it will have low wavelength because E equals to hc by lambda. Now, if this fellow is very high, of course, this will be very small. So, for smallest wavelength in Lyman series will be when Ni equals to infinity. So, lambda mean will be how much then? If you substitute R and this fellow 1 by 1 square basically on and 1 by Ni square. Ni is how much? Infinity. So, 1 by infinity will be how much? 0. Okay. It means the minimum wavelength lambda mean will be how much? Basically, lambda minimum will be how much? 1 by R, right? This is basically 1 by R. So, we'll draw all that Lyman series line for hydrogen atom. Before that, let us calculate that Balmer series also. Okay, for Balmer series, again we have to write that expression 1 by lambda equals to R into now 1 by NF will be how much? NF will be how much? Anyone in the class? NF will be how much? Very good. So you have to keep 1 by 4, right? Because 1 by NF square. Okay. So it means this is 1 by 4 and then you have 1 by Ni square, right? Now Ni can be 3, 4, 5 and so on. Okay. So how much will be the smallest wavelength? Anyone in the class? How much will be the smallest?
3.
Smallest I asked. Smallest wavelength when it will be? When Ni is
Infinity.
so you are bringing at means infinity. So lambda minimum will be how much? Basically, you have to keep that Ni is infinity. So this term will be 0. So R by 4. If you keep inverse it, so it will be basically come 4 by R. Did you get what I'm saying? So minimum wavelength in Balmer series of hydrogen atom will be 4 by R. So maximum wavelength will be how much now? You are correct. That is Ni equals to 3. Can you people calculate maximum wavelength? Maximum wavelength will be how much? So for this you have to keep Ni equals to 3. So 1 by lambda max equals to basically R times 1 by 4 minus 1 by 9. So if you solve it, how much you will get? If you solve it, how much you will get? Anyone? Anyone in the class? So you will get lambda max for Balmer series is 36 divided by 5R. Every people understood this? How you are getting? Any doubt in the class? Any doubt? Shall I proceed?
Yes, sir.
Okay. So if you calculate again a Paschen series for hydrogen atom, so again write 1 by lambda equals to how much? R. Then you have for Paschen series NF is how much? 3, right? So 1 by 3 square means 1 by 9 into sorry 1 minus 1 by Ni square. Now Ni can be 4, 5, 6, so on. So how much will be the maximum wavelength? Now when Ni equals to 4, right? For maximum wavelength. Is not it? Ni equals to 4, right? Okay. So if you calculate 1 by lambda max, it will be basically coming R into 1 by 9 minus 1 by 16. Okay. So lambda max will come 9 into 16 divided by 7R. Similarly, if you calculate minimum wavelength, so you have to keep Ni equals to infinity, right? So if you keep Ni equals to infinity, you will get minimum wavelength, that is lambda mean, and that will come 9 by R. कोई डाउट है क्लास में किसी को? Is there any doubt in the class? Anyone? Is there any doubt in the class? Is there any doubt?
No, sir.
Very good. So now I'll draw that spectral line for hydrogen atom, and it's really interesting. When you'll go for research or a higher study, you will get that in experiment also, and this class will really helpful for your future. Okay, we'll do research or any higher study. Okay, so if you draw this line, spectral line, so let us, this is assume this is the ground state, it means n equals to 1. Then you have other state, n equals to 2, 3, 4, 5. So Lyman series means electron is coming where n equals to 1. So this is 2, this is 3, 4, 5. So when electron is coming from excited state to n equals to 1 state, it is giving Lyman series. So this is all about your Lyman series. So when electron is making transition from higher state to lower state, it will emit photon, right? So from different state, you will get different energetic photon. Okay, so you'll get on series that is known as Lyman series or L series. So from when electron is coming from n equals to 2 to n equals to 1, this is known as L alpha line, Lyman alpha line. This will be your, when electron is coming from n equals to 3 to n equals to 1, it will give you L beta line. Okay, similarly this one will give you L gamma line. Okay, so this is all about your Lyman series. Now when electron is coming from n equals to 3 to n equals to 2, or n equals to 4 to n equals to 2, or n equals to 5 to n equals to 2, this one will be which series? This one will be which series? Anyone in the class? This one will be which series? When electron
Gamma series.
very good. This will be Balmer series. Okay. So Balmer series basically used to write H alpha, H beta like that. Okay. Now next series is which series? Paschen series. For Paschen series, when electron is coming from higher state to n equals to 3, right? So this is your Paschen series. Basically used to write P series. P series means Paschen series. Okay. Any doubt in the class? Okay. किसी को कोई doubt है class में आज का? Anju, did you get everything today? Any problem in the
Yes,
class?
sir.
Anushka,
Yes, sir.
Ruby,
Yes, sir.
Shekhar,
Sir.
Neetu. Okay. So this is all about today's class. What you have learned? All about that hydrogen-like atom, their energy expression, radius expression, then speed expression, then the spectral lines for hydrogen-like atom. Finally, we have learned about spectral line of hydrogen atom in details. Okay. So today I am leaving. Okay. Tomorrow we'll do more interesting problem based on this topic. Okay. And then we'll go for correction in that energy, speed, and radius due to the finite mass of nucleus. Then we will go to X-ray. Okay. I hope you people enjoying that class, right? Okay. Okay, then I'm leaving today. Okay.
Thank you, sir.
Okay. Thank you all. Okay. Good night.
Thank you, sir.